In this video, we'll talk about areas and definite integrals. Let f be a continuous function over the interval ab, then let big F be the antiderivative of the small f, then the area under the graph of f and x-axis can be calculated as f of b minus f of a, or the definite derivative of f from a to b. Okay, let's look at this example. Find the area under the curve of y equals x squared minus 1 over the following intervals. So a is from 1 to 3. So a is looking for the definite integral from 1 to 3 of x squared minus 1. All right. So first, let's find out the indefinite integral of x squared minus 1. That is 1/3 x cubed minus x. All right. And then, of course, plus c, but here we don't write it. We choose c equals 0. Okay. Then, we'll first find out, plug in 3, right? 1/3 3 cubed minus 3 minus 1/3, plug in 1 cubed minus 1. Alright, so this is 9 minus 3 minus 1/3 minus 1, which is 6 minus negative 2/3, which is positive, I'll call it 6 2/3, or if you can write it as 20/3. Okay, that's the A part. Now let's look at the B part. All right, what B part is looking for is the definite integral from -1 to 1 of the same function. Okay, we already know that is 1/3 x cubed minus x. Now we're trying to find the definite integral from -1 to 1. So plug in 1. We already did that earlier. That's -2/3. Then minus, plug in -1 this time. That's 1/3 of -1 cubed minus -1. So -2/3 minus, this is -1/3 plus 1. So -2/3 minus 2/3, which is -4/3. All right, so let's take a look of what we found here. So if you draw a graph, a rough graph of y equals x squared minus 1, it kind of look like this, right? Where this is -1, this is 1, and let's say 3 is here. So part 1 is looking for the area, this area here, right? And you can see this area is above the x-axis, so you get the result of a positive number. And B part is really it's looking for this area. And as you can see, it's below the x-axis. That's why you get a negative number.